Let's turn on the music. Hello. Just getting lost in the news here. So today I want to go over all the changes that we did so far. Do a little bit of a retrospective since we have a working version of a single sign-on. See what code was updated, what changes were made. Just go through the changes before we start adding more to LangFlow and expanding the system and just adding more functionality to it. So let's do that. Let's just go over all the features that we added. And yeah, okay. Yeah. All right. So what we did, we forked LangFlow GitHub project, right? We forked it into our own Bitbucket. Okay, that's the first thing we did. Why? Because the current project does not provide ability to set up or configure single sign-on. It has no single sign-on. So for deployment of LangFlow, we want to have single sign-on. And in fact, we want to have the same functionality as they have at DataStax. So you can see they have this single sign-on page right now here that allows you to use your Google sign-in and all the other stuff. And also have the ability to do just a basic form as well. Sign up. And in our case, we did the same thing. That's the kind of the way it looks. You come to our deployment, and then you see this button, single sign-on, to kick it off, right? We also have the ability to hide and show the login page as well. So right now we disable it because we just want our company users to go through a single sign-on, which is already configured with our employees' users, right? We don't want people to be adding users, deleting users, any of that stuff. They go through single sign-on, okay? So that's just what we did. We forked it and we added extra functionality. We also cleaned up a lot of stuff. There was quite several bugs that we found in the code base. So especially on the Python backend there, we updated the logging. We updated the containers, made them more production ready. So right now, for example, if I look at the logs of this system here, the backend, the Python backend here, we have what? Let's have a peek at the logs. Well, one thing we have to do is we have to disable the health checks from the logs, right? Just noise. So we'll do that later. So there's additional things we have to add, things we have to update as well. Now, actually, I just log in let's just go to the login page so you can see it, right? So there's a single sign-on. It kicks off your your single sign-on login page, and you can have your social media stuff here as well. You Google login, Facebook, all that stuff, and you just log in. And Bob's your uncle. There you go. You're in the system right now, okay? And there's my simple agent here. I just open this up here. There's my agent, okay? So it's very easy to configure through Keycloak. So we're using Keycloak as a single sign-on. We made it production ready. Everything is deployed with Terraform, right? So now if you go back to logs, we should have some logs right now because of the interactions here. So we can see some of these logs here, right? So they're all JSON logs. So we made them all JSON logs. So we can scrape them in Loki. And right now I'm in Google Log Explorer, but in Grafana and Loki is what we use to actually examine the logs, right? So we did that. We also updated the logs for the frontend as well for the React application, which is running as Nginx container. So we kind of customized them and added extra functionality to those containers, also made them a little more production ready. Remove some of the stuff that does not make production ready, right? So here you go. So you can see here's another JSON logs here, right? So there you go. Okay. We'll probably just adjust this in a second as well. This little thing here. All right. So there you go. You can customize the logs as well. It's a JSON payload, right? Here. And then it makes it easy, fast to build observability logs from these access logs, right? So you can actually get some good feedback from these type of logs. Now this goes to an ingress. So ingress is also Nginx. So we already have ingress logs for this application, but this is like a secondary information, right? To get extra information from the specific container. Okay. One more thing that we did, is major thing that we did, is you go into the root of the GitHub project here. You can see they have Helm charts, right? Helm charts are not the greatest. So we are the Kubernetes experts. So looking at from an expert point of view, there's so many things missing here, and there's so many issues with these charts, right? So we just created our own Helm chart as well with our own Helm repo, made it production ready, and we use Terraform to deploy it, right? So we created our deployment project here, and I'll talk about this stuff in a second. But you can see here, there's the deployment here of the IDE and the Postgres database. So we are running Postgres database here, not SQLite. So that's another thing that we change. And then we're here, we deploy our own Helm chart from our own Helm repo, which might make it public as well. So, again, there's quite a few changes here. Anyways, so that's what we did as well. That was a kind of major thing that we did, updated the Helm charts. So we did quite a lot of stuff with this project, right? So we basically wrote the Helm charts from scratch. We then forked the main project, right? And then we fixed up a lot of the, the kind of non-functional bugs, logs, and a couple other things. And then we added single sign-on, right? So now we have a full working application with a single sign-on. We also updated this admin page as well, so we can see here who's the user coming from, from Keycloak. You can see here, these are the Keycloak users. These are the other users, right, that were deployed initially, like LangFlow user, right, by default. That's going to be deleted in a second. So there you go. So that's a kind of little retrospective. So we did a lot here, right? And the goal was to really have ability to do a single sign-on, so we don't have to use a login page. And this is exactly what the data stacks did. So this is the managed version of LangFlow that you can actually go and log in, sign up for, and use. Now we have our own version, right? Running Kubernetes, secure as well. So this is state of affairs right now, okay? I should probably mention the bug that we had last session that took a little bit of time of debugging. So when we deployed the system in Kubernetes, we had an issue with one of the network policies for the backend system here, for the backend pod. So, and the network policy was really related to service mesh. So we run service mesh as well with all our deployments. In this case, we're using Linkerd in this cluster. So now you have to kind of, it creates a secondary layer that you have to kind of think about when it comes to debugging, right? So in our case, the problem was the backend, if you try to talk to the Keycloak from the backend, it was killing the connection. Sorry, not the connection, but it was killing the TLS handshake, right? So you can still make a connection, but TLS handshake was broken, right? So in this case, the linker was intercepting the specific request, and it was allowing the request to go through, but then it was breaking the TLS handshake. Okay, which is a bit different than, say, for example, trying to access Google or any other kind of external website from the container. It follows a different path. Linkerd does not intercept those websites, right? Now, it might be a little bit funny because you're making, just a curl to either Google or to our single sign-on. The problem is that the single sign-on lives within the same cluster, right? So the routing there is a little bit different. It knows that, it knows about the IP, where the ingress is, all that stuff. So in this case, Linkerd proxy intercepts that communication, right? So we had a bit of a issue with that. So it took a little bit of time to debug it. It wasn't an obvious issue because it's one of those kind of niche issues. So really what I did here is I just kind of created a debug container, and then I executed some commands in the debug container just to kind of get the understand what was happening. So in this case, we run TCP dump here to kind of capture all the traffic here information. So both on regular two different kind of networking interfaces, the local one here, and then all the other ones here that you have, which is really is the container, and all the other ones are really on the pod level, right? So the EF0. So after that, doing the TCP dump, also looking at the routing tables and net stats. So there's lots of kind of feedback coming from here. and running the curl command, we could see that it was getting blocked because of a single port. And that port is not involved in anything related to the RESTful API that we have in the backend component. It's really related to the handshake that happens when the mutual TLS happens between different Linkerd proxies. So in this case, whenever we do a request between pods, and those pods have Linkerd proxy, it does a mutual TLS, right? So it secures the communication, right? So again, we follow zero trust in our clusters. So without a service mesh, making requests between pods is open to anybody to intercept, right? So Linkerd does the mutual TLS, so it secures the communication between services, right, in your Kubernetes cluster. However, this case, it was breaking because the network policy was blocking one of the ports, right? And that port is only used when you actually make a HTTP request from your pod to the ingress of which goes to another pod, right? So it's a very kind of niche thing that happened there, a very specific request, and the way the IP tables or routing tables are kind of configurable Linkerd proxy, it just created that issue. So in our case, once we kind of examined all this data that came from TCP dump, we found that it was just missing a single port. So in this case, port 8443 is used by Linkerd for internal communication between their between the control plane and kind of other things that happen there. So just adding that single port fixed the issue here, right? So that was the fix, right? So we still have a nice secure policy here for the backend, both for ingress and egress as well. For the egress, we just allow it to go outside and talk to, for example, OpenAPI or Anthropic through 443. So it will make that TLS connection there. And internally, it would just use this port here, right? It's not going to use this port. So for internal communication, it's going to use 8443. Now that port is not listed anywhere, so you wouldn't see it in your Linkerd proxy. So if you actually examine this YAML file and you look at the different things that are used by the proxy here, right? So you have all this configuration here that comes with the proxy, which is automatically injected here, so you don't have to do much. But you can see that the ports they're using here to communicate, especially these ports here, are not the port we had to open, right? So that's why it was very kind of difficult thing to debug, because a lot of these ports here are obvious. They use just for kind of basic proxy stuff. That one is used more for internal stuff between like the control plane and the proxy container. So anyways, it was a very niche thing. It took a while to figure out, but if anybody wants these commands, man, these are just basic commands we just wrote quickly to debug network policies, to see the network traffic flowing within the cluster, to kind of understand the issue. So anyways, I'll probably post it somewhere if people want to see it or use it, because a lot of times you just don't know where to start. And you might be just kind of fiddling with the curl commands or wget commands just to see if the stuff is working within the cluster, that if the networking is up correctly. It's also, you might not have the tools installed, right? So I like to have a debug container always running, right? So in this case, we also created a debug container as well, where we add specific tools. So for example, something like a curl, right, which is a curl command here, should not be part of your container, right? So when you create a container for your Kubernetes cluster, you want to delete these specific tools, because that just creates opportunity for hackers to siphon off the data, whatever it is, right? So you want to remove any networking utilities that you can from your containers, and that means that you have nothing for debugging, right? So it's nice to have a nice debug container that has all the tools, all the networking tools installed, so they can just swap up containers, deploy the same pod, the same stateful set. It's just deploy the debug container, and you can just get into it, execute it into the container, and start debugging, right? Anyway, so that's what we did. All right. So yeah, a lot of changes here, right? Let's see. There's a few bugs we still have to fix in LangFlow. they might be kind of put on hold right now. I do want to start deploying additional tools here so we can start doing some of these workflows right now. So when you look at the simple agent, you can see there's lots of bundles here to create agentic AI workflows. We don't have any Kubernetes one, right? So the goal here first for Kubert is to create a DevOps AI engineer, or somebody that, an engineer that can actually deal with Kubernetes issues, right? So the next thing I want to do is probably just add a couple more features here, a couple more bundles of components here. So then we can just drag and drop Prometheus and Loki, and then we can just draw a couple graphs here to execute agentic AI workflows for DevOps, right? So this is running within the cluster, so has already privileged access to the tools. So we don't have to do much configuration, and that's the benefit here than running this as a SaaS model, because something like Datadog, for example, that's a SaaS model. You have to have additional stuff within your cluster to siphon off the data somewhere, right? In our case, we collect the data internally within the cluster. We're running, this tool, LangFlow, within the cluster. So now, when I want to use, let's say, a language model to inspect something, well, it's already running within the cluster, so it already has privilege. It's a first-class citizen already. So then I can actually just query safely my Prometheus logs, metrics, and stuff like that. Oh, and Prometheus, yeah, we did fix Prometheus as well, and the LangFlow here. Prometheus had a few bugs there, so we got it running. Now, you know what? We should probably inspect it in Grafana and see, because that's the thing. I have to do a dashboard as well for Fast API, or at least for LangFlow Fast API. So I'll just have a peek at the metrics here. So let's see what we're gonna do here. Let's see. Let me do maybe manually just search for any LangFlow stuff here. I'll just start with the namespace. Crap. Actually, you know what? Let me do it here with the builder, so I can just do it through the builder here. Namespace. So I just want to see if we're actually collecting the logs. So we did start a local server with OpenTelemetry in that Python backend to see. Well, we fixed it up, so there's a lot more information there right now than was before. Let me just run this. Just want to see if you have any metrics here. All right, sweet. So we have a lot of metrics for this namespace where LangFlow is deployed. What else are we going to do here? So scrolling through it just to see if there's any of the Fast API or RESTful API metrics that we have here. Yeah, okay. All right. All right, let me update this to, let's get the pod backend as well here. Now we can start coding some of these metrics here. Right. There's the metrics path right here. So we have some metrics here. So let me put the path as well. So I was expecting more. I'm just going to see if the scraper is actually scraping all the ones that I think they should be scraped. All right. I'm looking at these names here, and I don't remember that's what we called these names here. So I was expecting to be a request, not prober. I have to look at the names there. Maybe they're appending something to the name. But yeah, it looks like we have metrics probes. Interesting. All right, anyways, we have to kind of fiddle with the metrics here a bit and create some dashboards here. So let me just refresh this page a few times. Because every time we do this, it's supposed to generate fast API router metrics here. So we're supposed to get some metrics for every request here. All right, let me see. I'm not seeing the metrics I want to see. I was expecting to see. Maybe just because the names are different. There we go. It's a little bit better here. Okay. I'm gonna go and check and double check this here. That if that's the name of the request. Let's have a look at that. We should create a dashboard. Once I know the metrics names, I'll just create a dashboard and we put it into our Terraform code so we can deploy it with Terraform. Since we do practice dashboard as Git kind of methodology, so anytime we dump stuff into our we use Git to manage the dashboard, and then we deploy the dashboard with Terraform, and then we pick it up with an operator. So then you'll see it right away in your Grafana dashboards. What do I want to do here? So I want to check. I'll double check here the duration one per seconds here. Oh, it's not coming up. Okay, you know what? Let's go find this one here. In the meantime, you know what? I'll kick off the local version here of LangFlow. So make a backend, and then I'll just inspect it and just locally. Also, just deploy the front end as well. All right, let this run. I forgot where we made the changes already to Prometheus. I'm gonna have to find it again. Yeah, so we did do our own containers here. So we added to the project. So we revoked these containers, again, make it a little bit more production ready. Fix some of the obvious issues here. Same thing for the backend. We have a new container for backend as well. I added Teeny here to manage the zombie processes, things like that, standard things that we do with all containers. I guess you can compare it to what we did to what they did and see how different it is. Again, the focus for us is production, right? So it's not necessarily open source or contribute to open source. It's actually, we're more focused on the quality of the code, right? So I see a lot of people adding lots of code to this project. It's a huge project, but instead of focusing on the volume of code, or the features, we really focus on the quality, right? Because once you put the things in production, there's a price and cost to pay for every feature that you add, right? So we can have less features as long as they're good quality features. All right, let me see if I can run this local thing right now. So local 9090, I think. Is it 9090? Localhost 9090. Well, first, the site 3000. Let me see if the application is running so we can. All right, so the app is running. Let's see if you can log in. Sweet. Okay. Oh, I don't think the Prometheus is started by default. That's the thing. Localhost. Right. So by default, it's not enabled. Right. Okay. Let me just restart my backend. You know what? I'll just put in a breakpoint right now. So instead of running it here, I'll just run it from in debug mode, so we can actually have a peek at the here at the metrics, and maybe we can just do a quick dashboard quickly in Grafana. Okay, let's see what's happening here. Let's do this in Safari. There we go. So these are the metrics, the basic ones. Now, if I use the application a little bit here, refresh a few times. Let me see what we have now. Sweet. Okay. So let me look at these names here. So, okay. So these are like default names here. Okay. So let me look for these names in Grafana. See if I can find them now. Where's my Grafana? Grafana, where are you? All right. So let me just do this and like so. Nothing? I'm gonna have to inspect these metrics in a second here, see if I actually getting them, because I was expecting to have them the same way I have them here. So this is the code we published. So the changes we made. It's running on my laptop, obviously. That's the usual excuse. All right, let's see why we don't have it in our environment. So you know what? The best way to do this usually is to inspect your Prometheus scraper, see if it's actually scraping the metrics. So let's do that. So what I'm gonna do is let's port forward to Prometheus and have a peek at the metrics and then see if you can find the root cause of these issues. So let's switch to our deployment VS Code project here. And what I want to do here, I want to first of all get the Prometheus. Let me get the namespaces first. Forget what namespace it is. And we gotta first. Let's log into Google. We just got kicked out. All right, going back. So we are using a proxy, a Bastion host. So we gotta always tell kubectl that we're using. I'll set the proxy variable here. Well, so I want to get let me just get the NSS here. So yeah, it's an observability namespace. Let me just get the pods then. Get pods in N. And I want to get into, let me see, which one is it? I want to get into Prometheus. What's a good pod here? So we are running Prometheus stock here, which is Loki, Grafana, all packaged into one, and Prometheus operators as well. Let me see, which one is a good one to get into? So this is the one I want to get into, but there's two of them. So let's use a service instead. So we can actually go against both of these things here. Okay. Let me get the services. So we're going to port forward using a service versus a pod. Yeah. There we go. It's much better. All right. All right. So there we go. Let's use this one here. Not this. We are going to svc/this, and will be kubert, and the port is 9090. All right, let's see what we can tease out from the Prometheus. All right, wait, I'm running this in the same port. Oh, crap. All right, never mind. Let's ignore that fact that I put in the same port. All right, so let's look at the service discovery first. Let's see if it's actually discovering our. Let me turn off the other server. It's just Bub's getting confused. All right, let's pause this for a second. All right, shut up. All right. So there we go. So we do have the pod monitor running here. It's for the LangFlow. So there's 1 or 14 targets. Okay, cool. So that's good. Okay. Now let's see. Let's look at the targets here. All right. So show me more. Okay. So it is scraping. It is working. So yeah, so we have all the information here, so that's good. So we at least verify, confirm running. It is working. Now let's look up some of the metrics here. So it should have the namespace added to it, the metadata. So let's do that. And we can do it here in Prometheus. We don't have to do it in Grafana. All right, let's narrow this down a bit, just a bit. So let's look at the pods. What I want to do, I want to get a pod name here. So let me see if it will do it for me. If it does, if it has code completion pod. Crap. Yeah, I want LangFlow backend pod, this one here. Okay. All right, let's see what we have here. Yeah, I don't see any of the ones that we see in our dev environment. It is collecting the metrics from the pod, but not the ones I was expecting. Okay. I gotta look at this path. What is this path? Probes. Let me turn this off. And I want to go inspect not this. I want to, let's run this again so I can get the backend up and running. And I'll just kill this for a second. Just want to confirm the path endpoint here that we have. See if there's some funny business happening here. All right, let's generate some feedback for the observability. All right, there we go. All right, so I did see probes, some metrics. And for some reason I saw probes here. Now, and this is at the root, so this would be just probes, right? No metrics. Oh, crap. All right, I guess we're gonna have to debug this because I'm not seeing these metrics at all. Well, let me refresh the page a bit more, see if I can generate some of these things here. All right, let me get back to Prometheus, and first of all, let's put on a different port. Let's not be silly here. Let's put it 9080. Okay. Yeah, I'm not seeing the ones. Okay, so the expectation is that when you scrape, I'm supposed to get something like this, right? That's the metrics we're expecting. It's already generating this metrics here, so the scraper should pick it up as well. So why isn't it picking up? That's my question I'm having right now, and maybe there's an answer for this with the configuration that we have. Maybe we messed up the configuration, but let's just figure this out. Yeah, it's not there. Okay. Any metrics from here? No. Okay. Let me look at the lookup here. So a lot of times this will help you with the lookup here. So nope. Huh. Okay. Okay. So how are we going to debug this? So we already see that it's discovering it. So it's running the discovery well. So it's picking up the pod monitor. The pod monitor is picked up. Let me have a look at this in the label here. Okay, so it is looking for metrics, endpoint, and specific port on the container. So we just got to verify that's there. But it is accessing it, so I don't see any issues with, there's the port 9090 metrics. So that's the port we defined. Okay, so it is getting it's discovering the right pod monitor, and the targets also look good as well here. What was it? This one here. Yeah, so it's hitting metrics endpoint here. Okay, and the port is 9090. So that's all good. So it looks like it's something related to maybe a variable not set with our Prometheus. Let me see the properties that we set in a debugger just to get this going. So for a debugger, I have for the debugger. So I just have Prometheus port and Prometheus enabled, these two variables, okay? That's all I have there, okay? And for our deployment, well, let's have a look at the pod YAML quickly here. So what do we have? Prometheus enabled true, and Prometheus port is okay. So we have both of these things. Okay, so it seems to be configured and it's running. Let's look at the pod monitor. Let's have a look at that. See if there's any configuration issue with that. So let's get back into. Let's go back here. So let's kill this. Let me grab all the pod monitors in here. Yeah, let's go. Okay. All right, let's see what's happening. Oh, this is very basic. Okay, so it attaches the right pod. So both the port and the path are metrics. And is that the port that we have on the pod? Let's just have a see. So we have port 9090, but what's the name for this port? So there should be a container port here. Where's the container port? Am I blind? Where's the container port? Where's the hiding, bro? Where are you hiding? What? All right, so it is metrics and the port is 9090. Okay, good. All right, so in the pod monitor, you access the port by name. So it has to be metrics, okay? So the configuration is fine in Kubernetes. The scraper is working. Configuration is okay. So it looks like an application issue then. So we got to have a peek at the application, see if there's anything that needs to happen during the build. Maybe it's a build issue, container build issue. So, but right now we're good in terms of the configuration. Looking at the pod monitor and all the stuff that's configured with on the pod YAML. So yeah, so metrics, and the metrics is the endpoint. Now, why is the metrics endpoint here? So first, let's confirm it's actually mapped to metrics, because I'm not seeing anything coming from metrics, okay, right now. So yeah, why is it metrics? I think I used this metrics path from their own Helm chart when they have a scrape. Let me have a look at the chart, because I think I just copied that and I never verified. Maybe that's another bug. So if I go back to their Helm chart, let's have a look at the stateful set template here. Where is... Oh, they probably have in the values YAML. Okay, it's probably here. Yeah, here. Okay, so that's what they had. They had the pod annotation, so they had the using a scraper. So I just copy it from here. Now, is it actually /metrics in the application? Let's have a look at the application. So there should be a route for metrics in the app. That's the quickest way to find. Okay, let's just see. So just do a search, and the app. Where's the app? Where's the app? No, wrong one. Wrong one. I should really have better labels for these, so they're not that confusing. All right. So let's see if we can find, because this one is just launch at the port. There's no path here, right? So I don't know why. And this thing doesn't even work on metrics, right? I mean, it does the same thing. So it doesn't really care about the path here. It just goes from the root, right? So this might be just another bug in the code base. All right. Let's have what we're going to look here. Yeah, we just want to find the route. Where is the metrics route actually configured? /metrics. Well, it's nowhere configured. Okay, so they have it on the Docker Compose deployment here. But that's not defined in the application. This is just on the proxy here. Terrific, the lovely Go proxy, a server, reverse proxy. But that's okay. Well, let's have a look at the Prometheus YAML here. It just gets the root. So this might be just a bug in the code base again. I don't know why it's like that, but then in here to give it path prefix, but this prefix is only for the router here. You know what? The best way to test this is really just edit the pod monitor and see if I actually get feedback right now. Let's see. So let's do a live edit here. So let's just edit this. And what I'm going to do is I'm just going to remove the path here, make it at the root, not just the metrics. All right, let's see. So the port is still the same, but now I'm just getting from the root of the server. Now we do start two different servers in that backend. One is for the application and one is for Prometheus, and that's the way it's usually done with Python, because Python really has a problem. It's not the greatest backend runtime, so you have to deal with some of these issues. We can probably talk about in more detail all the issues of Python has, comparatively speaking, to the community of other runtimes. Let's just see if we can go into Prometheus again, see if there's a difference now. Let's actually refresh this a few times. All right, let's see if this is still working. If it's still hitting the, it's still up. So it's hitting. So even though we changed this, it's still up. So where is the new update? Where's the path? Oh, sorry, the path is here, right? So there's no more metrics here. Okay. So it's still working. Now let's have a peek at everything from, let's see if there's HTTP now. HTTP server. No, we're still not getting it, but you know what? Let's just go by namespace. And let's go by pod as well. So pod. Sorry, LangFlow. LangFlow. Okay, so let's see if there's a change here. If there's any new ones here. Just give it a few seconds. It takes about 5 to 10 seconds, depending on the configuration, to get this. So I'll just refresh this a few more times. Let me just grab one of those ones here. This one, okay. So my expectation is that we should have this one here. All right, so this tells me that there's definitely a bug with where Prometheus is configured. And I'm fairly confident whatever they had in the Helm chart is incorrect as well. That's a bug. Okay, let's see how we're going to solve this. So I do like to have some sort of a endpoint here, like metrics. But as you can see, nothing happens. It just goes to, it just gets it from the root. So it looks like the configuration in the fast API is, well, it doesn't care about the route at all. All right. Now, if it doesn't care about the route, I would expect the Prometheus to just pick this up. Yeah, still nothing. It scrapes every 10 seconds in this case. So that's plenty of time to get some of these metrics here. And just to confirm, if you're getting it in Grafana, let's just refresh this. Oh, this thing is so bad. Holy shit. All right. Looks like it's not getting picked up. Okay, let's have a peek. Yeah, nothing. Okay. All right, looks like there's another bug in the open source project related to Prometheus. Really fixed one of the bugs, so we can actually see the observability data locally here. So we have that now. The next step is, again, it's environment parity issue again. Works on my laptop, doesn't work in a cluster, right? Oh boy. So that excuse works on my laptop is something I'm just gonna keep on using right now with my bosses and say, hey, it works on my laptop, bro. It's all good. All right. I'm gonna run this in the debug and see what the hell is happening here, because this is just so silly. Okay. So first place to check is the main fast API main. So let's look at the main of the configuration. Just close all these things here. All right. So for backend, LangFlow. No, let's go base. Okay. So here, this is where we define the fast API server, and this is where we also define, there we go, instrumentation here for Prometheus scraper here. Where else do we have? So where's the Prometheus here? So there you go. So it's enable, it starts the server. So this is our little server here. Oh, here. And just ports. So there's nothing else here for the server. So it looks to me like maybe it's not configured. That's it. All right. So there doesn't seem to be a route except for, oh boy. Yeah. So it's definitely a bug. Oh, a bug. Oh, we just never added or properly configured. Okay. So at least it's adding the metrics here. So we know this thing, the instrumentation is working because we can see them. It's just the server configuration. So this just starts another server here. But this server, let's have a peek at this server. Maybe there's some, oh, this is WCGI server. Okay, so it's not even async server. So this is a synchronous server. Let's see where that is. So address 00, okay. And we have port as well. So we do pass the port. So that's the only thing we do. We pass the port here as a first variable, okay. Which is the first variable. We use the default. Okay, so there doesn't seem to be much of a configuration at all defined. Okay, so you know what I'm gonna do? I'm gonna create a new variable, call it a Prometheus endpoint, and then now the other thing I noticed is that we're not collecting anything from the server itself, the UVcorn, because Fast API so these are the Fast API routes I see here, but I don't see anything coming from the actual thing that runs the Fast API server, which is UVcorn in this case. So there's no metrics here for UVcorn. So that's another problem. So it looks like they never added those specific metrics. You know what? That might be a secondary thing. So for now, first thing to do is add a configuration here. So when I do start the server, I'm going to provide a path as well. Path is not necessarily really. It's already isolated on the port, right? So it's fine. So that's not an issue here. So what else we can do here? Let me think. What can we do here to make this a little bit better? Let me see if I can find the metrics path. It is picking up Linkerd. That's that's nice. Let's see, what can we do here? Let's see. So I want to limit this to, you know what, let me put a container here as well. So on the container name ID, no, just one container, which equals to backend container. Okay. What else? Let me limit this by job. So here we have multiple jobs here. So there's multiple scrapers running. So in this case, let's put a job in here. Job or job name? Let's do job. What jobs do we have here? This one here. All right. So let me see. I am getting the Python, which is good, but that's it. I'm not getting the stuff besides. So these are the Python here. We should have them here as well. Right. So we're just getting that. So we're getting everything up to here, but nothing past here. Now I did delete a few things from the Prometheus stuff exporter to be able to see this locally. Now let me look at the stuff I deleted. I wonder if there was a section there for the cloud, which would be silly, but you know, we are where we are right now. So so for the Prometheus instrumentation, so let's see, what would that be? I guess a service, telemetry service. Here, this one here. So let me look at the Git. Yeah, let me look at the Git. So I did a one big commit here, so all the files in one, just to easy to track. Here. I was expecting this to open on the left side, man, and on the changes, not on the right side with, that's weird. Well, that's interesting that the plugin just does that. I thought it would be more efficient just to open the files or have the files. All right. No. What's the name of the file? Open telemetry. Okay. Can't search by file. That's a bit annoying. Anyways, let me scroll down to see what the freaking changes are. I should probably do this in Git a little bit easier than doing it here. You know, let me do that in Git because it's just annoying. All right, so source, backend, base, LangFlow, and then there was services and telemetry, and I changed this one here, open telemetry. All right, let's look at the history of this one here. What? Where's the changes? So that's what I changed. It's line 153. Okay, so let me see what was there before. Here we go. So this is what was there before. Okay. And the problem we had, it was just going to here and never actually going into here. Yeah, it wasn't even using the Prometheus reader. Right. So they're assuming that's already set up. And then if it is, then just return it. If not, go here. The problem I found locally that it was never going to this. Let me put this back just the way it is right now. Just grab the whole thing. Just put this to the side. I wonder if it just runs this multiple times during the startup phase, and then that's what happens. But if that does, that's a problem. You shouldn't be running this multiple times. So here. Okay. So first this. So now if I look at the local output, let's see. Yeah, it doesn't have it, right? Like this is just so silly. Okay. Let's refresh this a few times. Yeah, that was the problem. It wasn't actually getting to all the data. Now it seems to be, it's the reverse in the cluster. It's getting this, but not the other. Okay, let me look at a piece of code, man, because it's wrong in one or the other way, man. So it's not correct. But which version is correct? So if I remove the top if statement, I have it locally, but it seems like I don't have it in the cloud. So let's step through this. Let's put a breakpoint in here. And just have a peek at this again. Because right now I don't have metrics, and I need some metrics in prod to figure out if the server's doing okay, if the RESTful API is doing okay. Plus, we're going to add a little bit more. We're going to add some messaging bus in a second, some caching, some Redis, some graph database, the usual stuff. So I want to have a little more metrics here. All right, so starting, there's, where's this coming from? This is coming from here. Open telemetry service. Okay, so when the service is kicked off, it starts this. Okay, and the service is kicked off by the service factory. Okay, so this is just going to the services. Let me see what else. I'll make this a little bit bigger. Oh, we don't need to watch right now. Okay. All right, so the lifespan is, okay, so the fast API lifespan, so lifespan is just something that happens, it's the lifecycle fast API. So you start fast API with the lifespan. So here, we pass the lifespan to the fast API object. So when it kicks off the server, it goes to the lifecycle from the lifespan. So the lifespan is where we start the service. Okay, cool. So I think maybe that's the problem. They're starting it here. Why do it in the lifespan, but why not do it here when the server is run? Hold on, doesn't make sense. So, They're doing it in the lifespan, but why not just do it here after you have the app, so it's already configured? Because well, the assumption is that the lifespan is already fully bootstrapped and the lifespan begins. But it it looks to me like that it would be better just to do it. Where's the stuff when you define the Prometheus? Where is this stuff here in the main? Okay, so they start the server here, but the lifespan is okay. Oh yeah, let me put a breakpoint here. Just want to see if there's the sequence of events makes sense. I'd rather configure the Prometheus right after I have the app already configured before the lifespan. So I like to have it configured before you kick off the server. Before the server started, I want this to be up and running, okay? That'll be my preference, and it should lead to better results as well, because you have everything configured before the server starts. It starts and the lifespan is executed, right? Hold on, why didn't this happen? So, get lifespan. Okay, they're calling it here. They're not even, okay, wait a second here. So it's a big issue for me here. Let's just do this again. Yeah, I'm not liking this create app right now. And I think what we should do, we should probably create a new session, or maybe in another session, build fast API, create app from scratch that's production ready, that can be used for any project going forward. You can just copy paste the code, create like a cookie cutter project. In Python, the cookie cutter is just a way to create projects, and then you can just run the cookie cutter command to create a project for you. So I think that's the best way to go forward, because maybe then I can come back and just replace my version here, because I see this happen a lot of time. People get into Python and they start fiddling, creating their applications, and you can see it's very random here. Like there's no structure here. So it looks to me like somebody just is learning on this project, right? Like they didn't cohesively design this fast API configuration. They just did it organically, which I'm all for learning. But for production systems, I want to be done in the best possible way. I don't want to go through this process of learning and every open source project learning. I just want to have the best version of the fast API server, because we know what that is, right? So a lot of times people say you can have perfection, right? Which is, to me, that's a bad premise, or maybe a bad sentiment, right? Or this whole ridiculous idea that perfection is the enemy of progress. That's a dumbass statement, right? Because it's an excuse, right? People don't want to release quality because they think they get bogged down in the process of creating perfection, right? Well, no, right? That is just, to me, it's an excuse. You can still have a good quality system and still deliver the quality and on time, and not to get into these ridiculous procrastination issues where people procrastinate, they don't invest in their skill sets, and then they said, people ask them to do something and they do it last minute and they say, oh, I just got it done. Well, and then you say, but it's not good quality. Oh, what you want to have a perfect? No, but I want to get close as perfection as possible, right? So perfection to me is it's an end goal, it's an objective, a hill we can climb against. You climbing that perfection hill, and we know what perfection is. We know the attributes of perfection, right? We can define perfection. Doesn't mean we want to get there, but at least we know what it looks like, right? At least hypothetically speaking, and practically speaking as well, we know what it looks like. We know what a perfect architecture is, right? It has specific attributes. It's difficult to get there, man, but we want to get to it as close as possible. And I think that's what's lacking in software engineering, because it's one of those disciplines where you can just do stuff, tear it down, do it again within seconds, right? You can't do this in civil engineering. You can't just build a bridge and destroy it, right? You can't do this, in electrical engineering. You're not going to build a circuit board and just destroy it. You can do it in a CAD system, obviously, in practice there. You can do simulations, but you're not really building the circuit board, you're simulating it, right? So, it's like simulating the system. You can't do it with mechanical engineering. You can obviously, again, simulate environments in CAD system, but that only gets you so far. You want to build something, right? Prototype it, and it's expensive. Hardware is expensive. Software is extremely cheap. It's dirt cheap to create, right? So we came up with this ridiculous notion of failing fast, right? Which coming from, obviously, from the Silicon Valley, and that's getting applied to everything. But failing fast again, it's a logical fallacy. You want to fail gracefully, right? And when you design systems, you want the system to fail gracefully. And anyways, I'm rambling on, but it's just like we create these almost these idioms or proverbs, and we use them as excuses, right? To not to deliver quality. And we never push back to business people when they say, hey, just give me something, because we want to deliver it. I guess make them happy. I don't know. Maybe there's just other things happening. You just want to get something out there. But quality is always sacrificed, right? Always. And I can see how this code here, scrolling through it, there's not much quality in this piece of code here, right? So this is your main entry point where it creates the server, but quality is not to be found in this piece of code, right? So anyways, let's see if you can fix this up a little bit. Anyway, so let me just see, let's debug this again and just see the workflow here, the process, how the Prometheus server started, how is it configured, what's happening here, and let's get through this right now. Okay, so we get the version. Sure, don't care about the version. We do the log configuration here, and then here's the lifespan, right? So lifespan, yeah. So we execute the lifespan here, and before we actually execute this lifespan here, we execute the telemetry service here, okay? So it's configured right before we create a fast API server. So I think I like to do this right after fast API is created, because I also want to be able to control what to scrape on, what not to scrape, right? You want to exclude some stuff from scraping, for example. Yeah. All right. So at least I know how it's running right now. So anyway, so this runs, and then it defines the method. All right. So we know from a fast API point of view how it starts, where it's configured. Now let me see why there's a problem here with this section here, not getting Prometheus reader, because you need the Prometheus reader to be able to get the Prometheus metrics from fast API, right? But I'm suspecting it's just going to go in here. And what is this existing provider? None. Okay. No. What is this? What is this class? Let me see. Right now, we didn't actually configure Prometheus yet. So let's see what provider we have. All right. So this is OpenTelemetry Metrics internal. So this is like the default provider, right? That we just picked up. Okay. So we have the default provider. What happens? Well, and then we set that. So we don't get the Prometheus provider here, right? So, okay. So let's run this again. Continue running. So anyway, so we have that configured. So the idea is it should come here second time, right, to get the Prometheus one or something. But yeah, so this is messed up. Okay. So you got the default one, which is just a Python runtime environment. So if you go back here, that's what we see here. And the Prometheus reader there is not, that reads actually the fast API routes, the request and response information is not here. All right. So I was actually right to delete it, but in my implementation, I see just that. I don't see this. Okay. Check the instrumentation is set up. Now that's a problem because it's not set up, because if it executes this here, which is right before fast API, then we get the fast API, and then we define the instrumentation here. See, there we go. And then fast instrument, it's just right here. It's rather than okay. So it's weird. It's just it's not cohesive, right? It's not, the sequence of events that happens here is just wrong. They try to check for this instrumentation to be configured here, and even the comment says, check if fast instrumentation already set up. Well, that's not how you check for it, right? This is just picking up the basic Python provider, but it's not checking if the instrumentation was set up already. That's not a way to check, right? You check for the existing, what is this? All right, so let's rewrite this. That's another thing we have to fix here. Okay. So I do like to have this somewhere else, not part of the live span configuration. And I would like to have it right after this, after instrumentation, right? So let me stop this. So if I was going to do this, and since it's open source, I can do this. I'm going to go and take this out of here. Okay. I don't think it should be there. Also the start here, that is, hold on, let me think. The start probably, oh boy, you know what? I can start it right away. I need to wait for the lifespan here. So I'm going to put it right at the end here. So I'm going to put it right here and then get the start part. So start, and I'm going to start it right away as well. Okay. And if it's a problem, then I can just create maybe a variable and just expose it to whatever this function here. Okay, just like that. Undefined service, why is it undefined? It was already cleaned up on my linter. Let me see. Yeah, it was. Sometimes this linter is just too aggressive for me, right? Just too aggressive. You can just wait for me to finish typing before it starts deleting shit, right? All right. So now, here, okay. So let me put a breakpoint here. Let's step through this again as we did before. And now I'm expecting a little bit different, slight difference here. Maybe a bit of an improvement. So it's configuring this. Here's the Prometheus stuff, right? It gets the port. Yeah, it's the port. Cool. So we're getting the configuration out of the way first before we start it. And then we start it. And now let's see. Exception handler. Oh, I see the exception handler needs updating too. Okay, now we instrument it. Now we get the service. Okay, let's see what happens now. What service is it now? It's down. Okay, see, this is what I would actually, I'm gonna also update this code as well. I don't like this. All right. So it is running. The only difference is we shift things around. It's still the same thing. Now I want to go back and remove the way I did it before. So this piece of code here, because now I know it's instrumented, so I just don't need this right now like that. Okay. And I don't need the existing one either, because now it has to already be, well, the instrumentation happened already. So if I move this like here, like so. All right, let me put a breakpoint here. Right, so now it configures the Prometheus as enable. And right now we're getting the provider, which is the Prometheus provider, the Prometheus meter here, okay? All right. So let's run this. So if I go back into here, well, I need to hit something here. Just see. Nope, let me see. Still nothing. What's happening? All right, we have it back. Okay, cool. Okay, so I think I'm gonna push it that way. I want to see, and this is still at the root. So metrics here, it doesn't matter. There's no here, just it's at the root. Okay, there's no configuration. It's just separated by port, right? There's, the fast API runs on one port and this runs on the other port. There's no route here. Okay. So I'm going to build it this way and see if, plus there's no problems here, right? I'm just going to the application here. Let me start a new flow. Simple agent. This is running locally. Is it still saving? So it's all good using SQLite. So we didn't break anything, and we just move things around from from Prometheus point of view. And the expectation is that once we deploy this, we want to get this and then all the other stuff as well, right? All right, let's build this. We already have the CI/CD pipeline built, so we're good to go. Let's just push these changes. Before I push them, I just review them quickly. All right, so we just moved them out of the lifespan into here. We're starting it right after the instrumentation happens, so that we don't need to check if it's instrumented, and then we just, okay, cool. So I'm happy with this. Let me push this. Stop this. Yeah, to start the activity here, you can see how many changes have been happened since I've been pushing stuff, right? They also fixed the Postgres issue that we found that took me like an hour to find. Finally, I'll show you in a second, and that kind of made me a little bit angry because I'll rant about it in a second. Let me just commit this. All right, so let this build. It's going to take about 5 minutes for the CI/CD process to execute. Now, what I had a big problem with, it took me a long time to find, is that they had an issue with Postgres, because they're testing locally with SQLite, right? So nobody really cares about Postgres, right? Which is strange, right? There's no test cases for Postgres. There's none of that stuff. So we're deploying Postgres. So even though we're testing SQLite locally, Postgres was broken. So if you look at the Docker here, the backend here, which one is it? This one? Yeah, this one here. So you can see they added this, right? Just like when you look at the blame, when was this added? It's like a day ago. They just added this, right? See, there we go. Where is it? Here, 3 days ago, right? So 3 days ago, we were actually working on this, and we used this thing as an example, and we were like, what the hell is happening? It's not working. This is because they install the Python Postgres libraries here, but then the binaries get installed within this image, the builder image, but they're not copied over, right? Because the thing that gets copied over is just the libraries directory, not the Linux binaries. So you have to add the binary, right? So, it's not an obvious issue when I'm just copying it and trying to make it better and making production ready. It took a while, and plus you only found out when you deployed it, right? So you have to go back and forth. But 3 days ago, right? This container has been created how many? 10 months ago, right? At least. So it's been like almost almost close to a year, and they didn't have this. So people tell me that they never tested Postgres, right? So it's one of those things where you ask yourself, what the heck, right? Anyways, whoever fixed this guy here, adding, they created Jira for this. So we did the same thing in our stuff. We added, this specific library here. But it makes you really angry that there's some other things they added fixes. I probably grab them as well. That in open source, again, there's a cost to open source, right? You're grabbing it, and they're making all these promises to you, but you running it, it's broken, right? And then what is the idea? Oh, go fix this, right? They're gaslighting you at that point. Oh, it's your problem at this point. Or you can participate, right? You can join the community and you can participate, right? And add to the community. But that's a problem in itself, right? You have to find the time to it. It's free labor, right? And what you're getting out of it, right? In our case, we are getting out of it. We're deploying it. But just in general, what is your incentive to actually fix some of these issues? And I can tell you that working with open source for more than 30 years right now, since beginning of 2000s, a lot of companies abuse the privilege of open source, especially the big companies, right? I think Pivotal is the biggest example. the Spring Java people, because they built a whole Spring project on backend of the backs of developers, open source developers, right? And a lot of times, early stages, before they got bought by VMware for like, what, 400 million, that evaluation was based on the code that people created, free labor created. Now, it was full of bugs, right? And the problem is that when we did try to engage with them to actually fix all these Java issues that we find, Spring issues, they didn't want to accept them, right? Plus, there was always politics, right? Now, we needed those fixed because, Spring was broken in our environment. It was literally broken, especially Spring security. That was awful, right? There was so many bugs in there. And it's like, they didn't want to accept those changes, right? Because of political agendas. They had their own way of doing things. They didn't want to take the code, right? We had a different issue. Shit is broken, production is broken, we need to fix it now, right? Here's production ready code, take it, right? But they didn't want to do it right that way, right? Because they had the other ideas, right? So there's always this struggle with open source, right? I do like open source, the idea, but it is abused by a lot of companies. Google should not be doing open source, right? The reason Google does open source, for example, TensorFlow, for example, is to vendor lock you into using TensorFlow or TPUs in their cloud, right? That's the only reason, right? Now, TensorFlow is an amazing project, and Google pays staff to sit there and fix open source issues because they have the money. So they actually rotate staff on TensorFlow project, and it's a huge project, right? TensorFlow is a big library. That's an example where, it's not really about the open source. It's just a lead magnet to get you into the ecosystem so you can use the TPUs, right? Because, obviously TensorFlow can, run with GPUs, man, but the idea is there to get you to use the TPUs, right? Not the GPUs. Anyways, so you got to think about open source and who's doing it, what they're doing, what's the reason, right? Because a lot of times, it's driven by business. It's a business tool. And it sucks when it's broken, and then doing fixes wastes your time. Fixes that should be done. Like, to me, adding a library here, something silly like that, tells me that it was never tested on that database, right? Because that means it would never work without the library, this Linux library. It's just not possible for it to work, right? So that kind of exposes them to saying, hey, yeah, we say we work in Postgres, but it was never tested on Postgres, right? Go ahead, take it, run on Postgres. And then it's not running. Oh, sorry. And it's like, oh, did you do it properly? Did you fix it? Did you plug and unplug the laptop, right? That bullshit that happens, right? That you're the victim now, like it's your fault. And it's like, oh, but I just got the code and it's not working. You must have done something wrong, right? But it shows they never tested this ever, right? Till like 2 days ago, right? Anyways, just annoying, right? Anyways, good for them that they finally fixed it, but they could have fixed it months ago, and it saved me at least, what was it, 2 hours of debugging, right? Trying to figure out what the hell happened. Moving on with the rents. So we're using Cloud Build as our CI. So let's see if this works here. There we go. So you finished building. Okay. So I'm just going to kill the pod. I'm just not going to go through the CD of the CI/CD pipeline. Just going to go kill it. So because the pull policy is always, so just gonna grab the latest container from the repository for a private repo. And just wait for it to start. I think Primogen was talking about perfection, right? Not getting stuck in perfection and not writing perfect code. There's no such thing as perfect code. I disagree. There's a concept of a perfect code and perfection. It's the idealized version of your code, and it's nice to have the idealized version because it kind of tells you where you can be and where you can get to, right? And we do this all the time in engineering, right? We create models. What is a model? It's an idealized version of the thing you're doing, right? You're modeling. Because the model can't be perfect, right? But you basically, the way to think about it is through principal component analysis. And that might be kind of fancy, but anything can be broken down as principal components, the main components, right? And then there's a lot of components in anything, right? So principal component analysis just finds the most important components of the thing. And then you have all the other ones, right? So when you model anything, you just want to model the principal components. So in marketing, we talk about the client or the idealist client. Well, it's based on principal components, right? In engineering, when you build a circuit board, you're looking at just the principal components to do a circuit diagram, not everything else, not all the ambient noise that's coming out, the heat. You don't do that, right? Because you want to focus on the core problem. And the core problem can be defined in terms of those components, the principal components, right? Same thing in software. You can take any software and break it down to its principal components and use them as an idealized version of your software. And the things, the secondary, the tertiary, the quaternary issues, like your audit, security, or monitoring, could also be baked in. But again, they're secondary, the tertiary, right? But you're still thinking about the core components, right? So, and that is your idealized version. That is the thing you want to basically think about, and that is how it leads to perfection, right? That's a path to perfection. At least that's the way I'm thinking about it. Okay, so this is running now. Let's look at Prometheus now, if it's actually scraping more. Let's hit the website a few times. Yeah, I'm not seeing it. It's still the Python one. Just give it 10 more seconds. I like this, the endpoint matrix, so that's nice. So I like that. What do we have here? I see more. Let's do it a few more times. Just give it a couple more seconds to scrape. And we want one of those metrics here. Let me just grab this and see if it's part of the index database here already or not. Nope. No cigar. Okay. So the next step is really to put debug outputs in the metric server to see what's happening. Now, you know what? Let's have a look at the logs here as well. Let's see if maybe if something is getting blocked or not. Let's see if we can just say last 5 minutes. Let's run this. All right. So yeah, I forgot. I need to suppress this health. That's just too much noise. So next time I'm in the code base, we'll remove the health and the health check from the logs because we don't need to see it. And this is just used by the liveness probe. So if the probe fails, we'll know we need to actually have the output in the log. Okay, so you know what? Let's look at the what's the thing I want to look at? The resource, the container. Let's see if there's any thing coming from Linkerd proxy. If there's any issues there. Let's see the timing. So there was some activity here. Let's see. Come on. What is broken with this thing? Move up. Oh my God. What the hell? Google. You know I love to hate you, but this is just ridiculous. Okay. What? I can't move this up now? Move this up? I can move the whole thing? Oh, geez. All right, so we can see this is the server runs on 7860, and we know that Prometheus runs on 9090. So let me do a search for 9090 here. See if there's any, no, nothing. Okay, well, that's interesting. I wonder if it's getting blocked by a network policy. But then this would complain, right? The target would complain. Let me look at the target. Right, so if this was down, you would know there's something happening, but this is actually scraping. So it's hitting the specific endpoints, and it's actually it's up, right? So this works. Oh boy. Yeah. Okay, I think I'm gonna have to just add more debug outputs to the Prometheus so I can actually see it in the log. So when the server starts, when we actually collect some metrics here, because right now we're nowhere. So the setup is fine. I think it's correct now. It's on the route. You don't need to specify any route. The instrumentation works because we see it here. So I want to see if there's any difference in our cloud setup. So this is another kind of environment parity issue where we just have you know what, let me curl that endpoint. Why not? So let's see if what it comes back with. So right now, let me see. Yeah, so it's 9090. So I should be able to hit this endpoint with kubectl execution, kubectl execute. Do I have a curl? I don't have a curl. You know what? Let me start a client. Okay, I'll start a client, run it with utilities, and let me just hit that endpoint. That's the best way to see. So let's do some debugging here, Kubernetes point of view. All right, so first I want to do is deploy a client. Let me just grab a client. So I like to have a networking client that I deploy with all the tools, which is, where's my networking client? Which I have it here somewhere in my test client. I think I call it test client. What do I use for the test client? I always forget the name of this container here. Oh, that's the one I want. Okay, I want this. Okay, there we go. Okay, so I'm just going to run a namespace. Do Kubernetes run. So just this is we'll create a pod. This is just a quick way to create a pod. Kubernetes LangFlow. The label's not important. So there we go. And we want to sleep infinity because we're going to exe to this one. Let me see. That's good. Okay, so let's run this. Oh, Google timed out on me again. Damn you, Google. Let's log in. I love to hate you, Google. It's the best. It feels good. It feels good to hate Google. They deserve to hate, but it also feels good. Haters gonna hate, right? Proud Swifty over here. All right, let's run this again. All right, so that's pod is created. Now I can exe to it. So kubectl exe. We have the name of the pod here, so we can grab this. Oh, that's annoying. Sometimes I'm just getting annoyed with these code completions here. Okay. Let's see if it has bash. Does it have bash? No, let's do sh then. Okay. What? What? What did I messed up here? Oh, it's a linkerd proxy. Okay, so we need to give it a, what you call it, a container name. What's the container name? Bloody hell. So Linkerd is a bit annoying sometimes. Now, I always like to exclude it from my test clients, but in this case, I'll leave it just to see if there's any proxy issues. And so it's just unnamed test client. Okay. So the container is test client. Obviously. And let me see if it has bash. I prefer bash over sh. It does have bash. Nice. Okay. So first thing we want to do is what? Right. Let's just get the service. So let's do ns lookup. LangFlow. What's it called? What's the name of the freaking pod? What's the name of the freaking pod? Oh, actually, let's just get the service as well. You know what? Let's just go by. Let's do a pod. Okay. Let's go by pod. Just grab the IP here. There we go. Just go direct to the pod. Just avoid all this Donnybrook here. Let's not get into some Donnybrook. Curl HTTP. So this is one to hit this one. Okay. All right, nothing. Now here, let's just hit the port 9090. Oh, that's interesting. I get nothing back. Let me just see if it's actually doing anything. It's doing a timeout. Okay. That is interesting. Why is it doing a timeout on this? What's the other port? The other port is what? We have two ports. So let's just hit. I wonder if this is just because of Linkerd. We might have to exclude our client from Linkerd for the service mesh. So this one is. Oh, what about health? /health. That's the route that we expose. All right, you know what? Let me start this again. So I'm going to exclude Linkerd just from this. So I'm just going to go and let's kill the client. Let me just delete the client from here. It'll be easier. Oh, I guess we have 5 more minutes. Damn it. Okay, let's do this quickly. So let me just delete this test client, blah, 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 delete. Now let's write a little command here to exclude Linkerd from so this is the image. Let me see. So what I'm going to do here is oh no, shit. Let's call this test client. So it's going to be my new script, test client. And I want to change the image. And the reason I'm doing this is so I can add annotations so I can overwrite the pod. This is a good thing for your Kubernetes exam if you're taking it. So I'm not going to add the volume of the specs. So all I want to do is just add. Oh wait, let me see. Do I need the container here? Fine. Let me add the container. So that's going to be test client, and all right. Volume mounts. I don't care about volume mounts right now because this is just to add certificates, and I don't care about this either. These volume mounts. All right. I think we're good for the rest. Well, it's going to let us know if it's broken. Anyway, so in this case, I'm just disabling linkerd. Don't need this label here with the annotation. So when I run this, it will start the client, but without the sidecar container that gets automatically injected. Let me see if there's any problems here. Invalid must be leading trailing. What the hell did I just do here? What I do? It should be in quotes. What happened here? And here. All right. All right, there we go. So right away it goes into the prompt. All right, so again, let's do a curl and let me get the IP address here. We should see a new test client here. It was my test client. Okay, cool. Running. Backend. Let me get the IP quickly. All right, let's hit it directly. HTTP style. That's how we roll. All right, and then now the port is 9090. I think we're getting stopped because of the network policy. Let me check this network policy. So let's do another window here. So this would be ingress. Oh, it's egress, but it's also okay. So, you know what? Let me put the. It's coming from. Oh boy, let me edit this quickly. I'm just going to remove this. Just do a little surgery here. So I'm going to just remove this part here. So it applies to anything coming to any port. Just for now. We'll change it later. All right. Let's put back some stuff. We need the port section here. All right, let's see if this is good. What happened? Oh, there's an I in there. Do I have an I in there? Jeebus. Why is this acceptable? It should fail. I put a freaking I in the port. I'm not going to judge you that much. Okay. And so if I go back now here, I should see a different result here. There we go. Cool. So let's see. We are seeing the rock. Okay, so it just gives me back the regular Python stuff. Okay, let me refresh. This thing a few times. All right, I'm going back. Let's see if we get better results. No, all right, so it's broken. There we go. So we have our answer. So the application is the part where it's actually doing the Prometheus processing is not happening. So you can see it just gives you just a basic, Python stuff. Okay. And when we do this locally, we get the Python stuff and we get this, right? All right. So there you go. So there's a difference between running it locally and running it containerized in Kubernetes, which is, well, it's infuriating right now. So there's environment parity here. So I'm gonna have to go put a debug here. We just verify it's not working. Something is busted, and let's just put some debugs and do it. Anyways, I'm gonna end it here. Probably debug it a little bit later. It's time for some business meetings. As people say on the web, this will be sponsored by blah, 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 but there's no sponsor. It's just me doing it, me paying for it. Anyways, goodbye. Later, guys.